going to start off with greetings and welcome, friends, in our continued look at sine and cosine and trigonometric functions. Yesterday we introduced the concepts of amplitude and period, being able to essentially vertically stretch and smoosh and horizontally stretch and smoosh these functions. All right, so for problem 23, it says state the amplitude and period for each function and then graph each function. So for problem 23 here, let's label some of our facts. A is equal to 5. K is equal to 1. So 5 is the coefficient, so to speak, of the trigonometric function. K is the coefficient of our angle input there, that variable there. So if I want to find the amplitude, that is going to equal the absolute value of 5, which is just 5. If I want to find the period, that's going to equal 2 pi divided by k, which is just 2 pi. Right? So now, as a means of graphing this, let's do this. So let's see, the amplitude is 5. So this is going to go as high as 5 and as low as -5. And it's got a 2 pi period, so here's 2 pi. And cut that in half is pi. Cut that in half is pi over 2. And triple pi over 2 would be over here, the 3/4 mark, which is 3 pi over 2. All right, and now I can simply graph some of these points. Now the cosine function, the typical shape, it starts at its maximum, goes to 0, drops down to its minimum, goes to 0, and goes back to its maximum. All right, so you want to kind of know those general points, but I suppose even if you didn't have that memorized, hopefully you're familiar enough with cosine that you could calculate cosine of 0 degrees, cosine of pi over 2 or 90 degrees, and go from there. So this is what the graph would look like for this equation, right? Something to that effect, right? Not too bad. So let's take a look at this next one, a little bit more complicated. So here the value of A is equal to -3. The value of K is pi over 2. So to find the amplitude, that's going to equal the absolute value of -3, which is +3. To find the period, I'm going to do 2 pi divided by pi over 2, which, dividing by pi over 2, is the same as multiplying by its reciprocal. And I think you would agree that these pi's would cancel each other out, right? And then 2 times 2 is 4. So the period is 4. And the amplitude is 3. And one other thing I want to point out, because the value of A was negative, this is going to be upside down or flipped. Right? Just like flipping a parabola sort of thing. So, to graph this, our amplitude is 3, so we're going to go as high as 3, as low as -3. Our period is 4. All right, so notice as a result of K actually having this pi in it, it's canceled out with the pi, and I can get kind of whole numbers or integers as my period, which is very helpful when doing real-world calculations with data that don't necessarily relate to pi, right? So if I, for instance, had something that repeated or oscillated over a 4-day cycle or a 4-year cycle, right, I could have an equation that would represent that. So let's see now. Oh, I didn't draw my other tick marks. Let's see. Half of 4 is 2. Half of 2 is 1. 3 times 1 is 3. Perhaps not that difficult to make that scale in this case once we realized it was an integer. And let's graph this. So a sine function, all right, starts at 0, and it typically would go up to its maximum, right? Sorry. But this one's upside down, So this one's going to go down to its minimum, and then go from there, 0 here, and 0.
So an A is negative.
Yeah, it just flips it upside down is all that happened. All right, so our curve would look something like that. So not too bad, and it's just really these are just different sorts of stretches and smooshes and flips on the regular sine and cosine function. So not terrible, not terrible. And then these problems are interesting where they give us an amplitude in the period and they want us to write the equation and they specify what kind it is. So for problem 37, they said that the amplitude is 35.7. So if the amplitude is that, then that means the value of A could have either been positive or negative 35.7, since the amplitude would equal the absolute value of A, right? So A could have been either of those things. If the period's pi over 4, well, I know that my little period formula is P equals 2 pi divided by K. So I want to figure out what this K is going to be. So in that formula, I'm going to plug in pi over 4 for the period. Equals 2 pi divided by K, right? So I've just plugged in what I know and I'm solving for what I don't. And then to solve this, I don't know, you could cross multiply, you could flip both sides. I'll flip both sides, why not? So 4 over pi is equal to K over 2 pi. And then I'm going to multiply both sides by 2 pi. And you can see that this and this will cancel, and this will cancel. I'll get K is equal to 8. Bless you. Bless you. So between this and this, I can now write the equation of the sine function. So y is going to equal plus or minus 35.7 times the sine of 8x, or 8 theta if you wanted. And that would be the equation of the sine function that has that particular amplitude and period. All right? So yeah, as long as you're familiar with sine and cosine a little bit, this isn't too bad. And then I like these problems from this batch with 37. Just kind of plugging in what you know, solving for what you don't, and writing the equation. It's not that bad. So thanks for watching, friends. Have a good day. Bye-bye.